Within the predictive modeling, we're going to talk about classification. And classification is the perfect example of using machine learning algorithms to help us predict the class of a variable. So, more specifically, I'll give you some examples over here. Assume you want to know if a child of age 7 has been diagnosed with ADHD or not. If the athlete student in our graduate school is specific student is going to graduate or not. If we want to predict if a student answer correctly to a SAT question. Again, this is a predictive model. The answer will be correct or incorrect. And I am using in this lecture logistic regression just because it's one of the most easiest type of algorithms or modules that you are familiar with in your studies. Of course, I'm not relying that you're gonna remember how to do logistic regression or the equations. I'm gonna cover them shortly. However, I'm not requesting you to understand all the aspect of logistic regression. At least you want to understand it. So I'm gonna explain it. However, the purpose in this video is how you can use a predictive model to classify new data and to predict their classes. Okay, and our example will be predicting if a person gonna have a second heart attack or not. However, I need to build the foundation first just to remind you what really was the concept. So technically, with regression model in general, we are trying to predict numerical or continuous variable, but as we saw in the previous video, we had a continuous variable, which was the number of heating units needed in specific houses. So it was a real number. It wasn't 1 0. It was the amount, how many heating units a specific house will need. Whereas today we're gonna specify more. We are looking at more like a categorical variable which has two values, 0 1 or yes no. Okay, so well, and that's what is called the classification problem. So we are trying to predict what category or sometimes is referred to a class. Essentially, we are going to try to create some sort of function that maps the variables, which are the input, to a discrete output variable. And that discrete output variable is going to be the category. So imagine that our previous case was how about I have two category. If the house need more than 100 units, I give it number 1. If the house needed less than 100 units, I will give it number 0. So that could be a very easy example. Okay, now give you something that you are really, and all of us, we are facing with our emails. Imagine the problem with a spam. So technically we are using the spam filter, and if you think about it, what kind of algorithm, how does the spam filter knows if this email I got goes to my spam filter or is it not spam? Now I would like to talk here about the differences between the classification that you see now in the predictive models and what you learned in your statistics and probability estimations. in statistics, we relied completely on the probability and the statistical zones where the equations that can really find us the estimates, and how the p-value of the estimates are important or contributing to your y. And here our y would be 10. Is it spam or non-spam? Okay, so and if you want to read more about the differences between what you're doing in predictive modeling or data mining per se, using algorithms, machine learning algorithms, under the classification specifically here, there is a really nice article by Harold in which he somehow compares the use of classification, the same function, logistic regression, for classification in the predictive modeling data mining algorithms versus the one in your historical statistical aspect that you learned with probability estimations. This is the example I gave you before. So you have an outcome, or the y in your case here is going to be yes, yes or no, and we saw that in those examples. So you're trying to model the probability of responding in each of these categories, conditional on the predictor variables, whatever those predictor variables are. And as I said, don't get panicked if you see those equations. The idea is just to remind you of the past. I'm not going to ask you about them, but it's really good to know what's happening under the surface, under RapidMiner, those black boxes, closed black boxes. What's going on really inside it? So the logistic equation, technically, so we are going to use a single predictive variable, just one. And what we have here, we are trying to find the probability of y given x. So the probability that y equal to 1, which is the left hand side of this equation, is given by the logistic equation, as you can see on the right side, which is nothing but, and you can see inside the parentheses, all you have here is basically the traditional regression equation. So the b0 plus the b1 times x, which is something you are familiar with in the past. So divided over 1 plus the logistic equation again. So what you are trying here to do is you get predict if y equal 1, and that could be either if that kid has the ADHD, or if that athlete student is gonna graduate or not, or if the student is gonna answer correctly on that question in SAT. Okay, now the B0 is nothing but the intercept. Let us put is x0, so let us determine this. So what you're gonna get only the intercept. So that's it, the probability of y equal to 1 when x equals 0. So this is what you get. Actually, if you have the y and x, is gonna cut your y at that value, the b0. Whereas b1 is the slope, which is gonna predict the differences in the log odds for 1 unit change in x. And if you remember, those are from your historical logistic regression. People like logistic regression because technically you have those two values. So I'll explain shortly the differences between those. But here it is. Imagine that this is the logit type function. It goes from 0 to 1 as the probability from 0 to 1. So imagine an email came, and Gmail tried to predict either to filter it as a spam or not spam. So if the cut value is is 0.5. Imagine in the middle. So the chances, and so this is over here. So the chances that if this email being flagged by Gmail that is with a value 0.7, then so you can imagine it's closer to 1, then that will be a spam. Anything less than 0.5, including the 0.5, is going to be considered a regular email, not spam. So that's why people like it, because everything is between 0 and 1. Imagine another problem. Imagine this is your likelihood of succeeding in this course. So your likelihood to succeed and to get an A, for example, it goes between 0 and 1. And imagine that you are imagine that this is the number of hours that you studied in this class or watched the videos and did the assignment. So the more time you spend watching and working on this class, so imagine at this value, like you spend 80% of your time that I would anticipate the student to spend in this class. So 80% of the time, so highly likely that value is going to be between 0.5 and 1, so you're gonna get an A. Okay, so that's why people like the logit. It's because it's very easy and simple to be interpreted. What else? Those four different images just distinguishes changes in your function. So if your intercept is bigger, so here's the intercept with the y, it comes at this value here, which is 0.1, where here, as you can see, it starts from 0.1, it goes to 0.2, 0.2. So you can see the starting point is a little bit, the function is a little bit, the age is a little bit different. Now, if the value is of the slope is different, which is the B1, if you remember, the unit change in the rise in comparison to the unit change of the runs. If it was bigger, you can see how the slope is going. So some definitions before we go into the actual practical part of this example. So sometimes we refer to this type of model to logit model, and actually what you are trying to do is you are trying to display the odds of achieving the value of y. And in logistic regression, we use the odd, which is the probability of the event divided by the probability of non-event. In our case, it's the probability of getting a spam over 1 minus the probability of getting the spam, which is not spam. Okay. And the log of the odds is naturally is the log of the odds, which is really easy. All we did here, we took the natural log for the both equation, and that's what you are used to see the logit function. That's all we are doing. So let us start with our case study now. So our data here, it has a couple of attributes. The first one is the age of a patient. Then we have the marital status of that patient, which is coded by 0 if it's single or never married, is 1 if it's married, 2 if it's divorced, 3 if it's widow. Now the gender, 0 if it's female, so remember that, and 1 is male. The weight category, 0 if the patient has a normal weight range, 1 overweight, and 2 if it's obese. The cholesterol level, because we know heart attack is associated with the cholesterol of a person. If you had it because of obesity or only of genetically. So the cholesterol level is the level of the cholesterol when the person was examined and when treatment was given. And maybe it's associated also with the first heart attack that person had. Okay, it was archived. Next, we have the stress management, which is also a binary attribute. So, if that person attended a course, so this organization are providing some stress management course. So, zero if it's no, it didn't take a course. Yes, he took a course or she took a course. The trait of an anxiety is a number between 0 and 100. So that was the last time that patient visited his or her doctor, archived the number of test anxiety being given at that specific time. And the second heart attack is a label that tells us if that person had a second heart attack, yes, or he or she didn't. Okay, so at specific period of time, those patients who had previous heart attack were really re-archived and monitored by that specific maybe health insurance or doctors. So we have the data about those patients. So here is our data. As you can see, all of them are numerical values. This is when you open it inside RapidMiner. And this is the training data because we have the value. We have the value of if that person, yes, no, had heart attack, second heart attack or not. We have 138, that means we had 138 patients in this data. Okay, and we have 8 attributes. Now the second data is new data that collected by the health insurance, and a lot of trend now that the health insurance are trying to really track every person with their numbers, so they might increase your insurance rate based on those type of a treatment that you did in the past. So you will notice those people who had heart attack or been diagnosed with cancer, their insurance rate goes up after being diagnosed, because they know that they will have to handle the payment of hospitals if that person, in this case, has this person got a second heart attack. So they want to put them under some type of stress management, lowering their cholesterol level, lowering their weight category. So all this becoming related. So the second data is our testing data, and this is the data that only has about 7 attributes, and it's a little bit bigger data. We have about 690 patients, and those are the ones that we do not have the why. We don't have their status of second heart attack, and we are trying to build a model from the first data, the testing data, to score the second data and to predict the value of each one of those patients. So this is patient 1, row 1, patient 1, who her age is 61, gender 1, so we know 1 means man, so this is the male. So a patient, he is either single or never married, if you remember our data. Weight category 1, so he was, if you remember the data here, so the weight category 1, overweight. Okay, and what else? Cholesterol level 139, and then the stress management course. Yes, he took the stress management course, and this is the number of trait anxieties. If it's got higher, that's mean worse, and we don't know the meaning between 50 and 100, but all we know that the higher the worse. Okay, so that's our goal. We're gonna try to predict those values, so like we did in our first previous example. We brought the training, we brought the scoring data, we brought all these inside. I showed you how in the assignment you can label the data from the beginning. We're gonna try to label it from the beginning here just for a change. So we're gonna decide that the second heart attack is the label, is our why. So you don't need to use set role operator inside RapidMiner. Okay, so now we have our data. Then I brought the logistic regression because here our case is y and no, so it is a binary model. So after we brought it and we run it, the model will give us a logistic regression model, is giving us the weight of every category. And as I said, in predictive model, we really don't look inside how the model did well, but we look at if we use other model, which one is better between both, or between 3 4 models, which one is better. Okay, so you add the apply model, and you bring the scoring data, which is the testing data we have here about those customers or patients who we don't know their status. Okay, we apply it to the model, and now the results here gonna give us what's gonna happen to those patients. And here a little bit different than what we saw in the linear regression. Not only we are getting the value of the prediction, if it's yes or no, of each patient. So remember that first patient we observed, we were looking at in the example. The logistic model told us like it's not, this person is not gonna have a second heart attack. Okay, and how much confident, which is really important here. Now the model not only is telling you the value, it's telling you how much confidence this model is on each observation, on each patient in our case. So in this case, for example, the model is 86% confident that this person, this patient number one, is not gonna have heart attack. Okay, the second one, this person is gonna have heart attack, and with 93% confidence that this person is gonna have heart attack. This is really bad. So let us see what we're gonna do. Here is a comparison between two people. I looked in the data. Um, Patient number 95 and patient 554. By the way, if you run the model, you might have different result than the one I'm showing you here, just because there were some changes in the data. So take a look at that. Those are two different patients that they have the same age. Both of them, they have the same marital status. Both of them are female, because when gender is 0, it's female from our data dictionary, if we saw at the beginning. Uh, so what the difference is between those two? So the person who the model predicted is gonna have second heart attack, he was overweight. This one was having, a good weight category. Okay, it wasn't overweight or obese. The cholesterol level, as you can see, much higher than that person. Not only that, this person stress management, attended the stress management, whereas this one did not. They had the same anxiety level. So the only two differences between those two patients, or three actually, is attending the class, the cholesterol level, and the weight category. And those two really are the one with this specific problem, are really influential in this in predicting the likelihood of having a second heart attack or not. Okay, so that's a really good finding. This is amazing. In a second, we were able to find some valuable information. You're gonna have the case in a complete written case to read the whole case scenario we are using in this example. Sonia, she works for this health insurance company. So she's looking at this data, and maybe what she's gonna do, she might want to improve the chances of this lady that highly likely is gonna have second heart attack, and maybe some weight management program she might advise her, or sessions to lower her chances of getting a second heart disease, second heart attack. And again, also the stress management, she might target it, those patients, not only her, all those patients in this data that we saw here, the outcome that have high chances to have a second heart attack. She might contact all of them, invite them to a free session of stress management, and then discussing some ideas during that session about how to the value of controlling the cholesterol and lowering the weight. Okay, so that's about our case. It's really short, but if you open the Word document, you will see more about the case. So please try to open the document. I give you step by step how you can follow the steps in this model and how you can use it. I'm gonna create another video about those steps, just the practical steps. If you know the theory now, you should be able to understand how those are generated. Okay, so that's it, and see you in the next video.